All right. Welcome, everybody. Welcome to Rochester Lifestyle Medicine Institute's Lifestyle is Medicine Lecture, our December 2024 edition. So excited to be able to welcome our guest speaker tonight, Dr. Milton Mills, who will be speaking on vaccines, the science behind immunization. I am Dr. Ted Barnett, the high-tech doctor with low-tech solution, also president and founder of Rochester Lifestyle Medicine Institute. And just a couple more announcements before we get to Dr. Mills. We have introduced a new sliding scale pricing program for our 15-day whole food plant-based jumpstart. People can now pay what they can. It's a pay it forward model, and the lowest price is $99, and the highest price that you can pay is $499. And the suggested price is $299. We just started this in December, and we had people pay $499 and people pay $99. So it's working. So we love it. Our other programs include the LIFT project for improving mood using the latest findings from positive psychology, lifestyle medicine, and neuroscience. And of course, we also have health coaching and both individual and group. And our 15-day whole plant-based jumpstart has now reached 2,500 people in 44 states and 9 countries. We've been doing it since 2018 with amazing results. Please take a look at our website for more details. We also run the Pale Blue Dot Community, which is a program of Rochester Lifestyle Medicine Institute, and that's where we host the video recordings of programs like this, of transcripts, chat logs, and we have multiple discussion spaces for people interested in having various conversations. It's also our learning management system where we run our 15-day whole food plant-based jumpstart and other programs and courses. It's not free because we're not advertising. Your eyeballs are not being sold to the highest bidder. So after a 30-day free trial, it's $5 per month. We figure that is not too expensive, and it helps us defray our costs. Dr. Milton Mills is our speaker tonight, and he practices internal medicine and critical care in the Washington, D.C. area, and has served previously as Associate Director of Preventive Medicine and as a member of the National Advisory Board for Physicians Committee for Responsible Medicine. He has been a major contributor to position papers presented by PCRM to the United States Department of Agriculture regarding dietary guidelines for Americans. Dr. Mills has published several research journal articles dealing with racial bias in federal nutrition policy. He frequently donates his time practicing at free medical clinics and speaking at hospitals, churches, and community centers throughout the country. He was featured in the attention-getting films What the Health, The Invisible Vegan, They're Trying to Kill Us, A Prayer for Compassion, and Vegucated. A major focus of Dr. Mills' patient advisement and lecturing is the use of diet change and nutritional measures to improve our immunity and reduce risk for prevent, cure, and or lessen the severity of major chronic diseases. And so now, Dr. Mills, I will stop sharing and I'm going to ask you to turn your camera on and for you to start sharing. So welcome aboard, Dr. Mills. It's so good to have you.
Thank you very much, Ted. I really appreciate that. And I actually like that bio because it's concise, but it touches on, I think, the important points of what I think is important and what I try to do. So thank
Good.
you for that.
Absolutely.
All
Absolutely.
right. And so tonight we're going to be talking about our immune system and how vaccines work with our immune systems to protect us from potential life-threatening and debilitating illnesses. And I developed this talk.
So, Dr. Mills, why don't you go ahead and start sharing?
Okay. All
And
right.
I'm going to disappear. I'm going to be
Okay.
here with you, but just invisible.
So this lecture again was developed during the COVID pandemic to help educate actually employees that I work with at the United States Census Bureau and elsewhere to help them understand what the vaccines were doing, why they were important, helpful, and could be trusted. But obviously, before we can kind of talk about vaccines, we have to have a basic understanding of how our immune system works, and then we'll talk about how vaccines interface with our immune system. So we'll get started here. And this is health and wellness. in the age of COVID. And we're going to talk about how our immune systems and the vaccines work, and also what role diet plays in enhancing our immune function. Um, and so, my goal, as always, is to follow the admonition of Proverbs. It says, with all thy getting, get understanding. And that's what I hope we will all come away from this lecture with, is a understanding of how our immune systems work, how vaccines work with our immune systems, and why we can trust them. So I think before we can even really talk about how our physiology functions, we have got to take a step back and look at what we are supposed to eat. Because, and this is, I personally think this is critically important, because so much of the research that we have access to that is being done is actually being done on people who eat meat, and people who have a sort of standard Western style diet. And the issue with that is that we have very compelling evidence that people who are plant-based, that their physiology and their the functioning of various organ systems are significantly different as compared to people who are eating meat. And the reason is because we are truly herbivores, and we should be eating an entirely plant-based diet. And by now, over 100 years worth of research has shown consistently and conclusively that the more we depart from a strictly plant-based diet, the more we open ourselves up to increased disease risk, chronic disease, and shorter lifespan. So this is just a quick overview to kind of point out that we are plant-based, and we should be strictly plant-based. It doesn't go into all of the detail that one could go into. If you really want a very thorough examination of the anatomy and physiology of human beings as compared to meat eating versus plant eating mammals, to see that we truly are strictly plant-based, I would encourage you to go to my website and look, or you can even find this on YouTube. My lecture, Are Humans Designed to Eat Meat? It explains in great detail why we are strict herbivores. But that's important because it directly impacts how every organ system in our body will function, including our immune system, as we will see. So again, Homo sapiens, we are strict plant eaters. And the fact that human beings are departing from that diet means that we're getting sicker and dying sooner. And what's really interesting is that when we look around the globe, as formerly more agrarian-based countries and societies start to industrialize and adopt Western dietary practices, you see a concomitant increase in allergies, autoimmune diseases, chronic diseases like heart disease, high blood pressure, stroke, cancers, and very interestingly, you also see increased prevalence of psychiatric disorders like depression, anxiety, and violent behavior. So it is really clear that our diet impacts every aspect of our health, our mental functioning, and who we are as a species. And so when you look at asthma, for instance, asthma increased tenfold in Western countries from 1960 to 2000. And when you look at the diet in Western countries, you see that there was a massive increase in the consumption of animal foods, meat, processed meat, and processed plant foods that have had their fiber removed and turned into essentially toxic compounds. Since the 1950s, type 1 diabetes, multiple sclerosis, and Crohn's disease have increased by over 300%. And again, when you look at the social milieu in Western countries, this coincided with the easy access of both refrigeration, as in refrigerators, so that you could keep animal foods fresh, but also the advent of industrialized agribusiness, where you now had factory farming raising huge numbers of animals that have been slaughtered and made available to people. And along with this change in diet, there's been just a massive increase in disease. The prevalence of type 1 and type 2 diabetes is projected to increase by 54%, from 54% to 54.9 million Americans between the years 2015 and 2030, with an annual death rate that will also increase by 38%. Breast cancer rates in women, and this is really shocking, have increased by 8% in women less than 40 years old. So women younger and younger are starting to be diagnosed with breast cancer. And I would argue it is directly related to the fact that children are being fed huge amounts of dairy and meat from a very young age, whereas formerly that was not the case. Colon cancer rates have increased by 9% in the United States in people under 55 years of age between 1995 and 2015, and colorectal cancer rates continue to increase by about 2% per year since the 1990s. And so the upshot is that all of the major diseases and death in Western countries result from our animal food-centered diets, because we are not eating the foods our bodies are designed to eat. And these things are plagues of our own making, and they could be prevented by adhering to a plant-based diet. So let's move on and talk about the gut. And people may be scratching their head saying, wait a minute, I thought we were going to talk about our immune system, so why are we talking about our gut? Well, the reason is because most of the immune tissue in our bodies actually resides in our gut. And when you think about it, the gastrointestinal tract is actually our major interface with the outside world, and therefore it has to be lined from start to finish with immune tissue to protect us from potential pathogens that could enter our bodies through at any point along our digestive tract, because once you get into the intestinal tract, the lining of the intestinal tract is only a couple of microns thick, and that's to facilitate the absorption of the nutrients and energy that we can extract from the food that we eat. But you can also easily end up allowing the introduction of pathogens and or antigenic compounds that could cause allergic responses if we didn't have an immune system to police that barrier. So it turns out that our GI tract educates and primes our immune systems. Phytochemicals and antioxidants in plant foods can decrease risk for infections and cancers and decrease inflammation. Conversely, if they aren't present, those things are amplified. Bioactive compounds produced by the right kind of colonic bacteria in our microbiome can affect our physiology in a number of beneficial ways. Colonic microbiome produces neurotransmitters and other bioactive compounds that can decrease risk for depression, anxiety disorders, and dementias, as well as enhance immune functions by the production of things called cathelicidins and other antibacterial compounds that are produced when we provide our microbiome with the right kind and the right amount of fiber. And for instance, we know that activated immune cells circulate throughout the body to our lymph nodes, spleen, and other lymphoid tissues after having been activated through compounds in cruciferous vegetables. Phytochemicals in cruciferous vegetables such as sulfophore. Anyway, you see the work. Are potent inducers of phase 2 detoxification enzymes and also function as long-acting antioxidants in and of themselves. Isothiocyanates and indoles are glucosinolate derived degradation product formed by hydrolytic actions of human microbial flora that have been shown to be chemoprotective. And that reduce the risk of various kinds of cancer, but they also enhance our protection against infectious agents, again, through the production of compounds called cathelicidins and others. So we've all noticed that babies, when they pick up anything, the first thing they do is put it in their mouth. And, you know, most of us as parents, guardians, aunts, uncles, we tend to say, oh, don't do that. That's nasty. But the question we should be asking is, why are babies programmed to put things in their mouth? And the reason is, it is the way that they train their immune system to know what is normal microbial flora in their environment versus what is abnormal. And by inoculating their all of this lymphoid tissue with these antigens and bacteria from their environment, by again putting it in their mouth, the immune system learns, oh, this is not anything I need to be afraid of. This is something that is normal for our environment. So again, we only have about 2 meters square of skin, but the total surface area of our gut is 400 plus meters squared. And as I mentioned before, most of our immune tissue is actually within the length of our GI tract. And so the reason that babies put these things in their mouth is that they are teaching their immune system to know what is normal versus what is not normal. And we know that studies have shown that when children are raised in these excessively, quote, clean environments where everything is treated with antiseptic and the bacteria are killed off, their immune system doesn't learn what is normal versus what is abnormal, and then tends to hyper react to everything it sees. And that is when they have a tendency to develop multiple allergies and even autoimmune diseases, because their immune system, again, just becomes hyper reactive to any antigen because it has never learned what is normal versus what is not normal. So just a point about the Dunning-Kruger effect, which is a type of cognitive bias where people with little expertise or ability assume they actually have superior expertise or ability. Why? Because they watch videos on YouTube. This overestimation occurs as a result of the fact that they don't have enough knowledge to really know what they don't know. And this is important because during the height of the COVID pandemic, you had people watching ridiculous videos on YouTube and coming out to assert themselves as experts on vaccines and on immunity, when they really had no or very little idea of what they were talking about, and the little bit of knowledge that they had really led them astray. So we want to try and avoid that mistake. So and just as a general overview analogy, you can think of your immune system as your armed forces to protect you against the pathogens, both within your environment and also those that may arise within your own body, like precancerous cells that could go on to form life-threatening tumors. And like our military, our immune system is organized with different branches that perform different functions. So the generals, or that sort of direct the response of our immune system, are the T cells, T helper cells, because they have the ability to recognize what is you versus what is not you. How do they do that? Every cell in your body has a unique set of proteins on its surface, which are effectively ID badges. And if they come across a cell or an organism that doesn't have the correct ID badge, then they sound the alarm and marshal a response to get rid of this invading organisms. T cells organize response to any foreign invasion, and then they tell the other cells in the body how to respond. And you can think of B cells as being sort of like your Air Force, because B cells manufacture the unique antibody proteins that are specifically designed to attack a specific invading pathogen and destroy it, either kill it outright or code it so that it will be recognized by macrophages, which are giant amoeba-like cells that can eat and destroy bacteria, fungi, and even cancer cells, and also natural killer cells, which are very toxic to cells that have been identified by the immune system as being a threat to the body. And so your T cells tell these cells how to respond, when to respond, and in what force to clear an infection. Natural killer cells, neutrophils, and macrophages are also like foot soldiers in that they are the first and last line of defense for protecting us against disease. So it's just like if you're in the kitchen and you're cooking something and you accidentally kind of cut yourself. Well, bacteria can immediately start invading through that breach in your skin defense. And if the bacteria are kind of a normal bacteria in your environment and don't have any uh, extra toxicity or ability to cause disease, what will happen is neutrophils and maybe even some macrophages will immediately come to the site. They will actually kind of create a little wall around the site, which is why you'll see an area of swelling and redness that's kind of firm, but you'll notice that for the most part, the infection will not penetrate beyond that area of inflammation. And then they go into the infected area and they literally eat up the invading bacteria and kill them. And eventually, you may even notice pus being drained from the area. And what pus is actually dead white blood cells that have engulfed so many of the invading bacteria that they've died, but they've killed them. And assuming that infection can be kept localized, then the bacteria are cleared, and then the cleanup crew comes in to remove all the dead cells and debris, and then the fibroblasts start mending the defect and forming a scar that will close the wound, and voila, you are back to normal. But in some cases, invading organisms are for God's sake, the word is escaping me, but they have severe enough pathogenicity that they cannot be contained by a localized response. They can actually get into our bloodstream, and viruses are very good for this. They will actually take over certain cells in the body and turn those cells into virus factories, and they start churning out just tons and tons of virus that takes over more and more cells, and they hijack the machinery of the cell to make copies of themselves. And what ends up happening is then we start to feel very sick. And when we get a systemic infection like that, then the immune system has to organize a response at the cellular level. So what will end up happening is macrophages will ingest some of these bacteria or viruses, digest them down, and then go to a T cell and literally say, look what I found. And they present to the T cell unique pieces of these invading pathogens that they can be easily recognized as not us. The T cells then send out chemical messengers to B cells to start to multiply like crazy. And they literally go through a library of B cells looking for the one specific B cell that makes an antibody that will latch on to this particular virus or bacteria and kill it. And so it's really kind of wild to realize that we have almost an infinite number of B cells that each make unique antibodies. And the way we develop immunity to like the measles or chickenpox or mumps is that the T cells will tell the B cells to start to multiply, and they literally go through until they can find a B cell that makes an antibody that matches the measles virus or the mumps virus or some other pathogen. And when they identify that particular B cell, they tell all the other B cells to chill out, stop multiplying. And that one that makes the effective antibody, they then give it orders to multiply itself billions of times over. So that you now have hundreds of millions to billions of these B cells that then start cranking out these antibody proteins that can then find every single measles virus or mumps virus or you name it, code it, kill it, and then have it removed from our system. And once that process is complete, once they have cleared all of the invading organisms from or pathogens from our system, then we actually get, quote, over that infection. And that process from start to finish typically takes about 2 weeks, sometimes 3 weeks. But when that process is going on, it requires huge amounts of energy and body resources to mount that response. And because everybody's immune system is somewhat different, some people may not make as effective antibodies as others, or they may have other coexistent health conditions that allow the infection to proceed at such a overwhelming rate that it actually can kill them before their immune system is able to adequately respond to the infection, or they may suffer permanent organ damage from the runaway inflammation. And that's why we've learned to use vaccines to train our immune system to recognize and respond immediately to potentially deadly pathogenic infectious agents. And when a person is vaccinated against a disease, then their immune system is able to respond in a matter of hours or a couple of days versus 2 weeks, and they keep the the infection from ever becoming overwhelming. So if you think about it, if you're old enough, like I am, you might have had the measles or the chickenpox when you were a kid. But once you have it and get over it, you never have it again. Why is that? That's because once that infectious agent has been cleared from your body, there are a number of B cells that are called memory cells that live essentially for the rest of your life, like you do, and they constantly secrete enough anti-measles antibody in your bloodstream that whenever your body encounters a measles virus, it never gets a chance to set up an infection because it's immediately grabbed and destroyed. It's like you have the most wanted list with pictures of these pathogens posted throughout your body. And as soon as they appear, they're grabbed and they're destroyed. And so what a vaccine does is it will take a unique part of an invading organism and introduce it to the body so that it's not enough. It's not a complete virus. It's not a living virus. Or it's a weakened virus, so that it is not strong enough to set up a full-fledged infection, but it's enough to stimulate your immune system to make antibodies against this organism so that you don't have to get sick and go through that whole 2-week process. And that then protects you from succumbing or to this infectious agent when you encounter it later on. So importantly, the immune system is responsible for natural infection and vaccine-mediated immune system training are ultimately mediated, guess what? By messenger RNA, because it's the messenger RNA that tells the B cells how to make appropriate pieces of or the appropriate antibodies. And so to extend this military analogy, we know that any country at war on multiple fronts will be less able to fight off new challenges. And that's why individuals with multiple chronic illnesses were more likely to get severe disease or die from COVID infection, because if their immune system in their body is already using a significant amount of its energy and resources to deal with some chronic illness or chronic infection, then when they get challenged by something like COVID, it is much easier for a strong pathogen like COVID to set up an overwhelming infection. And this picture that I'm showing you is meant to illustrate what the United States had to deal with in World War II. In World War II, the country was confronted with very powerful enemies on both sides of on the Atlantic and the Pacific side, and that put a tremendous strain on our country's resources. And we had to actually restrict the manufacturing of consumer goods so that we could pump all of the available resources into manufacturing the necessary weapons and military materials to fight off this huge infection. And for a while, it was touch and go as to whether we would be successful. And a similar, again, situation is faced by our bodies when confronted with these very strong pathogens. So this is a quick video
Developing
on how
vaccine
mRNA
is
vaccines
usually
work.
a very lengthy process, taking on average 8 years to get approved. Since a few years, we have the ability to create mRNA vaccines, which can be developed much faster. So how do these vaccines work? Are they safe? And how do they compare to traditional ones? But first, you must understand how the immune system works. When a virus enters your body, it will attach itself to one of your cells and inject its DNA or RNA into it. This is like a blueprint for your cells, containing instructions on what the cell has to make. So in this case, the virus's RNA will tell your cell to make more copies of the same virus. They become factories, assembling new copies of the virus that can infect even more cells. But don't worry, our bodies have a defense system for foreign intruders. The immune system attacks any protein, virus, or bacteria that does not belong in our bodies, but it takes a few days for it to learn how to attack the intruder. Meanwhile, the virus factories are running non-stop, quickly replicating the virus and spreading it in your body. In other words, you start experiencing symptoms of whatever has infected you. After a few days, however, your immune system will have figured out how to attack the virus and will start producing antibodies. These attach themselves to the virus, preventing them from infecting more cells and marking them for destruction. As you can see, the immune system is remarkable, but it's slow to mount an attack. That is the reason why we can get sick in the first place. So to give it a helping hand, we developed vaccines. The main idea is to train your immune system to recognize and fight off an infection before it has occurred. Almost like showing your immune system a mugshot of the virus and saying, if you see this, kill it. There are various types of vaccines, but let's take a look at the new kid on the block, mRNA vaccines. To understand how they work, let's take the COVID-19 pandemic as an example. You might have seen pictures of the virus with its distinctive spikes. These spikes allow the virus to attach to specific cells in your body and infect them. Now, here's the key idea for the COVID-19 vaccine. What if we could train our immune system to recognize these spikes by having our own bodies produce them? To do that, researchers took the virus's blueprint, its RNA, and isolated the part responsible for producing the spikes. Armed with this blueprint, they created mRNA, or messenger RNA. This is a special form of RNA that can enter your cells and give them instructions. In this case, the RNA contains instructions to build the spikes of the coronavirus. Not the virus itself, just the spikes. So mRNA vaccines contain instructions for your cells that tell them to build a part of a virus in large volumes, almost like giving them a recipe to follow. Once this is happening, your immune system kicks into action and starts learning how to attack these intruders. Again, it takes some time for the immune system to fight off these spikes, but you won't get sick because it's only the spikes, not the virus itself. And that's it. Your immune system has learned how to attack the spikes of the coronavirus. It destroys all the spikes and even breaks down the mRNA vaccine itself. The only thing left in your body are special B cells or memory cells. These can linger around for months or years until the same virus infects you again. When that happens, the B cells can produce the correct antibodies right away, preventing the virus from spreading and making you sick. What's interesting about this mRNA technique is that it's relatively quick to develop a vaccine as soon as we know the DNA or RNA sequence of a virus. And secondly, because the vaccine only makes our bodies produce a tiny part of a virus, we cannot get sick from it. More traditional vaccines use weakened versions of the actual virus. This also triggers an immune response, but could also give you mild symptoms. Now you know how mRNA vaccines work. But don't take my word for it. All sources used to make this video are listed in the description below. Check it out if you want a more in-depth explanation. Give this video a thumbs up if you found it interesting and consider subscribing to the channel. Thanks for watching. Until next time.
Okay, so the question is, if the vaccines are protecting us from getting sick, why do we feel, achy and fevery and sick or are ill after we get a vaccination? Are these symptoms COVID side effects? No, they're not. They're actually caused by our immune system. What? What are you talking about? These symptoms, the fatigue, the muscle aches, the loss of appetite, are orchestrated by chemical messengers released from white blood cells called cytokines. And the cytokines are the messengers that the T cells sends out to the other immune cells in our system to tell them to start to replicate, to start to make antibodies and do all the things that they need to do to clear an infection. So it's effectively our immune system has put out a biological requisition for scarce resources, because the fact is that we can only expend so much energy in a 24-hour period. We can only manufacture so much protein in a 24-hour period. And your body wants to requisition as much as possible to fight off this infection, not to have you out, building sandcastles or carrying on with, your paramour. And there's only so much of these resources to go around. And as in World War II, the federal government requisitioned it for the military so that you couldn't get refrigerators, washing machines, new cars, and all those sort of things. But it allowed us to manufacture all of the resources we needed to fight a two-ocean war. Likewise, when we respond to infection, our immune system has to clone hundreds of millions of T cells and B cells and other immune cells. And then those B cells have to churn out gigantic amounts of proteins called antibodies to flood our system and get rid of this infection. This requires a tremendous amount of energy, protein, vitamins, minerals, and plant-derived phytochemicals. And since we can only expend a limited amount of energy in a 24-hour period, we have to ration those nutrients and energy. So your body's goal in making you feel ill is to literally force you to lay your butt down. You feel tired and achy, so you don't get up and go out to the club and try to go dancing, throwing away energy on non-life sustaining measures. Your immune system wants you to allow it to use your limited available resources to gear up and fight off the infections that challenge you rather than go out dancing and carrying on. Well, why the fever though? Well, think about it. Warm things work better. That's the same reason we warm up our car engine on a cold morning, because the warmer it is, the better and more efficiently it functions. Now, some people also experience a loss of appetite. What's the rationale behind that? Well, it's because unless you are suffering from malnutrition or starvation, which most people aren't, our individual cells have enough internal energy to last them at least 48 to 72 hours at a minimum. Therefore, our bodies don't want excess energy floating around your bloodstream for bacteria and pathogens to take advantage of. And so it doesn't want this additional energy available so it can be commandeered by the pathogens that are invading your body. So your body makes you not want to eat for a while to deny energy and nutrients to these invading organisms and infected cells. This is analogous to in the Middle Ages when people lived in walled cities. When they saw an invading army coming, they carried as much crops and food into the walled city as they could, and they burned the rest because they didn't want food available to keep that invading army fed. So, and not everyone will experience the same symptoms to the same degree. Unfortunately, when I get sick, I rarely lose my appetite. I wish I did, but I just don't. So, because you didn't have severe fever, muscle and joint aches or fatigue, doesn't mean your immune system isn't working. It's just that your system works more, well, just differently. And again, because you didn't have the severe fever or muscle and joint aches, doesn't mean your immune system isn't working. We're all different. Our immune systems react to given pathogens differently. So if you have these symptoms, realize all that means is that your immune system is responding to that vaccine and making the antibodies you need to prevent you from getting sick. And the importance of reducing our appetite is illustrated by people with uncontrolled diabetes. People with uncontrolled diabetes tend to get runaway infections that cause tissue death, gangrene, and that can lead to amputations and even overwhelming sepsis and death. And the reason is bacteria, fungi, and viruses can multiply faster than our immune cells. And they can multiply faster than even medications can kill them. Doubling time for mammalian cells, such as your immune cells, is about 24 hours. Whereas for bacteria and fungi, it can be as little as 20 to 30 minutes. So that means that if they have enough energy to keep them multiplying, they will always outstrip our ability to destroy them. So denying energy to invading organisms is an effective strategy for helping to control them. So just some very quick ways to get rid of some of these COVID myths. COVID vaccines, mRNA vaccines do not affect or change our DNA because mRNA does not interface with our DNA. It operates in the cytoplasm of the cell. COVID vaccines don't affect or harm fertility. There are no microchips in any COVID vaccines. That is just so silly. Getting COVID will not, COVID vaccine will not give you COVID. 97% of hospitalized COVID patients were unvaccinated. The side effects of the COVID vaccines are not dangerous or unexpected. Again, fevers, muscle aches, joint aches, and fatigue show that our immune system is responding appropriately. No one has died from being vaccinated with any of the mRNA vaccines. I don't care what the legends and nonsense on the internet and YouTube say, because in most of those cases, what happens is someone who was very, very sick already came down with COVID, they got vaccinated, but unfortunately it wasn't enough to stop the runaway infection, and they died from the COVID infection, not the vaccine. There have been, at the time I prepared this lecture, there were 4 reported deaths associated with the Johnson & Johnson vaccine out of 8.5 plus million people who are vaccinated from a rare clotting disorder in women between the ages of 18 and 55 years old. But it is ludicrous to say, oh my God, we can't take the vaccine because 4 people died when it saved over 8.5 million. And COVID vaccines do not make anyone magnetic or give off electricity. I'm just going to skip this because we're running, getting short on time. Unvaccinated people have been shown to be 20 times more likely to die from COVID-19 than people who are unvaccinated. Now, this is where it gets like really interesting. And this is what I really want you to pay attention to in terms of the differences between people who are plant-based versus those who are not plant-based. It turned out that during the COVID pandemic, a study in the British Journal that was done in 6 different countries, looking at healthcare workers, this is before the advent of the vaccines, showed that people who are plant-based had a 73% reduction in the risk of developing moderate to severe COVID illness. And that is mind-blowing. That means that these people were 73% less likely to either get come down with the infection or develop severe disease. And there are many, many reasons for this. Plant-based diets are rich in nutrients, phytochemicals, vitamins, and minerals. This chart here shows that people who were plant-based had only 27% chance of coming down with disease if they ate fish. The fish didn't help them. Fish is not health food. It made them more likely to get sick. But that is compared to, your baseline omnivore. And then the people who were eating the, high meat, high fat diets were almost 500% more likely to get severe disease. This data was taken from France, Italy, Spain, Germany, United States, and Great Britain. So plant-based studies have hypothesized that an unhealthy dietary pattern such as Western diets, which are higher in refined sugars, processed foods, red and processed meats, can be pro-inflammatory and have negative health effects. And so basically this showed that this is a projection, which is essentially saying that if people were plant-based in these 6 countries, there would have been over 500 million fewer deaths from COVID, whereas low-carb diets would increase the deaths by close to 500 million. So let me be clear. While this and other studies show adhering to a plant-based diet will make a person resistant to becoming infected or developing severe disease, does not make us immune or impervious. So everyone, including those who are plant-based, in my opinion, should be vaccinated. All right, let's talk a little bit about long COVID. Long COVID are symptoms associated with COVID that persist more than 3 months after the disease is allegedly over. Estimates are 1 in 8 people will suffer long COVID. Estimated incidence, 50 to 85% of hospitalized unvaccinated people, 10 to 35% of unvaccinated people who don't require hospitalization, but only 8 to 12% of vaccinated people will come down with long COVID. Long COVID is more common with the original Alpha and Delta strains versus the now prevalent Omicron variant. Long COVID symptoms can include neurologic symptoms, chest-related symptoms associated with breathing, psychiatric symptoms such as brain fog, depression, and so forth, chronic pain, chronic fatigue, sleep impairments, and just functional problems in sort of being able to get back into work and do your activities of daily living. Turns out Omicron-related long COVID is associated with more myalgias, muscle aches, and mental health problems such as brain fog than the original variants. Many people with long COVID were shown to have pre-existing conditions such as asthma, allergies, ADHD, diabetes, chronic fatigue, insomnia, mental health diagnoses and frailty. And this chart shows that over on the left, you see those who are less likely to get long COVID and more likely to recover, people with no pre-existing conditions, males, people who are affluent, I wonder why. Initial illness or symptom was few symptoms or asymptomatic, people who were less sick with the COVID illness, people who were fully vaccinated, and people who were able to rest during their initial illness and weren't out trying to, still run wild and work. And because again, remember, you only got so much energy to expend it. If you're expending it on things other than fighting off the infection, you're not giving your body's immune system its best shot to get rid of that infections. And when antivirals were given promptly during the initial illness, that also lessened the likelihood of long COVID, and of course, people who weren't reinfected. People who are more likely are people who had pre-existing conditions, people who are female, people from low income circumstances, people who had very florid illness with a lot of symptoms, people who were more sick and required hospitalization, people who were unvaccinated or undervaccinated, people who were unable to rest during their initial illness, people who did not receive any of the anti-COVID, antiretrovirals, or antivirals, not retrovirals, when they got ill, and people who were subject to getting recurrent infections. Symptoms for long COVID are symptom focused. Stress symptoms are treated with respiratory muscle training, endurance exercise, pulmonary rehab. Cognition issues can be treated with hyperbaric oxygen therapy for 2 months, showed improvement in the mental functioning and mental brain fog. People who had loss of their sense of smell were treated with a novel therapy called platelet-rich plasma intranasal injections that showed significant improvement. Hyperbaric oxygen therapy improved depression symptoms, high definition. And this is crazy because I think this is just a very sexy way of saying electroshock therapy. But they said high definition transcranial direct current stimulation improved anxiety symptoms. Sounds a lot like electroshock to me. And interestingly, one study showed that giving people, but this has only been done in one study and has yet to be replicated, metformin twice a day showed benefit for preventing long COVID. And I just want to toss out the idea here that metformin works by decreasing glucose production by the liver and helping to maintain a normal serum blood sugar level. And I would argue that a healthy, whole food, plant-based diet does the same thing without the potential side effects of metformin. And there was no benefit shown for horse dewormer ivermectin. All right, so gosh, man, there's so much I want to show you guys. I just want to show you how fruits and vegetables impact your immune response. So this shows how our body responds to the Pneumovax vaccine in terms of a type of antibody called IgG. You can see that if you're eating more than 5 servings of fruits and vegetables per day, you get a much more robust response to that vaccine than you do if you're not eating a lot of plant foods. And this is a study it was drawn from. And this is talks about cancer, but it's kind of true for infection and as well. Immune system effectiveness does decrease with age, but plant-based diets can counteract that. Natural killer cells, which are, again, our first line of defense against virus-infected cells, against cancerous cells, are enhanced in people who are on a plant-based diet, and they recognize and destroy these cells without being sensitized. Berries, fruits, vegetables boost natural killer cells number and activity. Cruciferous family vegetables and other plants increase the ability of B lymphocytes to produce antibodies. Mushrooms increase IgA. IgA is the type of antibody that is in our secretions. So it's in your nasal mucosa secretions. It's in the secretions that line your airway, and also in the secretions that line your gastrointestinal tract. Why is that important? That's important because that is your first line of defense against an invading organism. If you've got high levels of IgA, then you can complex and kill off these organisms before they have a chance to set up an infection. And look at this. This shows that eating mushrooms markedly increase the secretion of IgA for up to 2 weeks after a single meal, just one meal. You get this massive boost in IgA secretion, which again forms your first line of defense against invading organisms, and it can last for 2 weeks. And obviously, if you're continuing to include mushrooms in your diet, it's going to just keep that secretion level way up there. So garlic increases natural killer cells function, as do a number of spices, and intraepithelial lymphocytes are stimulated and programmed by cruciferous vegetables. I am going to kind of skip ahead here because I know I'm kind of at the end of, so this just talks about the importance of chlorophyll, green vegetables, and these slides will be available to you guys so that you can actually go through the parts that I'm skipping over. Minerals like zinc, selenium, vitamin C, and D3, which is not a vitamin, are critically important for immune system functioning. Every immune cell in your body has a receptor for D3. If your level of D3 is not where it should be, then your immune cells cannot function properly. It's like having policemen who haven't been trained or don't have weapons to fight off the bad guys. And mushrooms increase and augment immune function and also help stabilize our clotting mechanism. And want to just mention D3 is so important because it is often misunderstood. And we know that colds and flu become more common and depression becomes more common during winter months. And the reason is likely because D3 levels fall because of less sun exposure. And so for that reason, I think everybody should take a D3 supplement because you have to get 30 to 60 minutes or more of noonday sun exposure over your trunk and upper thighs to make the minimal accepted amounts of D3. Most of us cannot do that, particularly during winter months, but even during summer months. And people with darker skin need even more time in the sun to make adequate D3. The US RDA is too low for adults. Adults should take 5,000 IUs a day, and it's essential for immune health, muscle function, cancer suppression, and for preventing depression and anxiety. All right. With that, let's see. All right. I wanted to kind of touch on this information about vaccines and Alzheimer's prevention, but I'm going to have to refer you to the presentation that was done by Dr. Paul Schultz on August 15th.
PCRN conference.
Thank you, Ted. I appreciate you, man.
So,
And
Milton, I'm going to interrupt you for just 1 second.
uh-huh.
Okay, but we are going to continue with you for as long as people want to stick around. I just want to respect people's time. I'm going to ask you to stop sharing for just a minute, if that's okay.
Sure.
And I'm going to share myself, and because so this was I just want to finish up because we have reached 8:30, but we are going to move into the lobby because I think this this conversation is just getting going. And I just wanted to tell you a little bit or remind you a little bit about what we do here at Rochester Lifestyle Medicine Institute. We have our flagship program, the 15-day Whole Food Plant-Based Jumpstart, and these other programs which are ongoing. We do the Jumpstart every month. We actually have 2 in January at different times, so that people from different parts of the world and with different schedules can join us. We have started a new sliding scale pricing for Jumpstart. We call it Pay It Forward, and prices range from $99 to $499. The regular price is $299. We thank you all for attending. Please aim your phone at that if you'd like to make a donation. I'm sure Bob will put the link in the chat as well so that we can, so if people would like to donate, they can. And I'm going to stop there and go back to Dr. Oh, what happened? What did I do? Stop. There we are. Okay. There's Dr. Mills. So Did you have more on your presentation that you wanted to show?
Yeah, I'm just going to go to my epilogue, and then we'll cut to Q&A, because the
Sure.
information on vaccines and Alzheimer prevention is a deep enough topic that I can't really do it justice by skirting over it. But I would encourage people to watch Dr. Schultz's presentation. What the main problem I have with his presentation is that they did not account for people who were plant-based. And as we've seen, people who are plant-based have very different immune systems. They're much more robust, they're much more resistant to disease, and they are less likely to have amyloid plaques in the first place. So I'm not sure that we can take that data that says having vaccines protects you against Alzheimer's and apply it to people who are plant-based, because they are less likely to have the amyloid plaques, they have lower levels of inflammation, and their immune systems are so much more robust in ways that we still don't understand. You just can't make one-to-one comparisons. So let me just go through my epilogue, and then we'll do our Q&A. All right.
I'm going to put the link actually to that. I'm going to put the link to that lecture in the chat if people want
Yeah,
to.
please do. Yes, absolutely. The fiber in our microbiome is something that we really need to understand much better. There's paradigm shifting research being done on the microbiome showing it influences and modulates every organ system in our body, every aspect of our health. And that means that much of the work that's been done on human health heretofore that did not account for the role of the microbiome has to be revisited, revised, and rethought. It's becoming clear the food we eat modifies, modulates gene expression through direct epigenetic effects on our own DNA, but also through indirect effects, or the lack thereof, mediated by the 39 trillion microbial cells of our microbiome. Ancestral humans ate 100 to 120 grams of fiber every single day. Modern humans are lucky if they get 30 to 50 grams. And that means that, and the plants that they ate were from a wide variety of plants. And so that means that our body really needs much more and much more varied plant fiber than we're used to getting to really reach optimal health. We cannot have an optimally robust, healthy, and diverse microbiome if we're consuming only 30 grams of fiber a day, which is the recommendation from the RDA. It's not enough fiber substrate or for the bacteria in our guts to manufacture all of the very physiologically active compounds, neurotransmitters, hormones, vitamins, and other phytochemicals our bodies need to keep our organs and organ systems functioning normally and at peak capacity, while also protecting us against inflammation and acute chronic diseases. We will likely eventually find many health problems that we thought were phenotypically discrete diseases were in actual fact just the disparate manifestations of dysbiosis in different tissues and organ systems. And if the scientists doing research on the human microbiome are studying the microbiomes of people eating predominantly animal and processed foods, by definition, they can never and will never arrive at the full truth of how our microbiomes can improve and optimize our health. So with that, I want to say every time someone visits Popeyes, KFC, Burger King, Wendy's, McDonald's, and the supermarket cemetery, i.e. the meat counter, they are making another payment to the Grim Reaper. They are effectively committing suicide on an installment plan. These dietary choices are helping to fuel the ongoing emergence of pathogens that can jump from animals to human and cause deadly epidemics and pandemics. It's also clear the profitable use of antibiotics by animal food producing industries also contributes to excess human disease and death by creating antibiotic resistant organisms. We must ask ourselves, who normalized dining on death for human beings? Who taught us to turn our bodies into walking graveyards? Where did we get the perverse idea that pleasure and happiness require health-destroying habits and the indulgence of recklessness, cruelty, environmental destruction, and the abuse of other living beings? What happened to our caring, our compassion, and our common sense? Why do we sacrifice our lives and our health on the altar of momentary gratification? Who stole our souls? We have become far too comfortable with disease, dying, and premature death. The reason diseases run in our families is because dysfunctional eating habits run in our families. The reason pandemics continue to decimate our societies is because we continue to damage and destroy our environment with abusive and destructive animal-based agriculture and wet markets. If we want our individual and collective lives to be different, then we have to do different things. We can decide to be different. We can change to a plant-based diet and enjoy good health, longer life, compassionate living, and also better and more robust immune function. We in the vegan and plant-based community must stop trying to keep up with the meat-eating Joneses on matters of health. Because of what the Joneses eat, they have heart disease, diabetes, cancers, dementia, depression, allergies, autoimmune diseases, and early death. They are not our role models. Western medicine and Western societies have been seduced by the lie that drugs and medications can fix the results of ongoing bad behavior and a lifetime of dissolute living. Tragically, in many cases, our human-made chemicals only temporarily conceal but don't correct the underlying problems and damage. We have abdicated responsibility for our health and that of our families and patients by allowing profit-driven marketing campaigns and or misguided medical institutions and pharmaceutical companies to dictate how we even define health and how we try to treat disease. We do not need to chase every shiny object or fear-mongering study thrown out or pushed out by institutions and researchers that don't understand the power and importance of plant-based diets and lifestyle. The chronic diseases that afflict us did not fall from the sky at the behest of some malevolent God. They are the consequences of our own actions. As such, it is within our power to change our behavior and improve our health. We can start this process by redefining what is actually considered optimal human health. We were all born without preferences. Nobody asked for fried chicken, ice cream, or pork chop in the delivery room. The unhealthy things we eat, we learned to like. We can learn to like healthy foods instead. We can change for the better. And I don't know who's putting the hearts in, but I love you for that. Thank you.
Bravo, Dr. Mills.
This is just some additional resources. Ted is also going to help me send out the articles that I reviewed to put this together. I'm telling you guys, there's just so much we can be thankful for and trust in when it comes to having a plant-based diet. So with that, I want to open the floor up for questions.
Great.
And thank you guys for hanging around and paying such close attention.
Ah, brilliant, Dr. Mills. Thank you so much. And Dr. Graff, you want to appear? Are you okay? I know you got other things going on. Dr. Graff is our medical director, and there she is.
Hey.
Hey, how are you?
Hi,
Live
everyone.
from-
Dr. Mills, a wonderful presentation. Thank you so much.
It's absolutely my pleasure. Anytime I can share this amazing news about what a good plant-based diet will do for us, I'm thrilled to have that opportunity, because I'm telling you, we are the arbiters of our own demise by the way we choose to eat and live. But equally importantly, I want us in the plant-based community to understand that we can't necessarily directly apply research done on meat-eating populations to ourselves, because our physiology is different. Our systems function differently, and we need to take that into account when trying to understand what constitutes risk reduction and a promotion of overall optimal health.
Into that problem all the time with patients is, if they're eating whole food, plant-based, really healthy diets, like, well, I'm not sure it's going to help you as much as it would help everybody else by taking whatever, right? Like that may be part of the recommendations, but the recommendations are made for people who are eating the standard American diet in general. So for them, yes, it makes sense to take it. But for you, I don't know. The study's not there. You don't have it. So
And I want to see us do that research. That's where I think the great frontier is to look and really define what constitutes optimal health and what is appropriate for people who are plant-based versus those who aren't.
certainly needs to be done. Although if it basically people say, well, if I eat a healthy diet, then my statin isn't going to help me as much, so I better eat a bad diet so I can take my statin. We kind of shooting ourselves in the foot, which I'm pretty
Those
sure
people need to be locked up.
well, I'm pretty sure there's quite a few of those folks, but Anyway.
Oh my God. No, that, yeah.
Tons of questions in the questions, and we're never going to get to all of them, but I would one of the questions came from one of the doctors that would say, wouldn't getting a de novo chickenpox infection wild type be the best protection versus a vaccine using only a part of the genome of the virus?
That's an excellent question, because people who had chickenpox don't tend to need boosters. Whereas people who had the chickenpox vaccine need to get periodic boosters. And it's very clear that when our immune system responds de novo to a wild type virus, it has many more antigenic points that it makes antibodies to, which appears and at least theoretically can give a more robust and longer lasting immune response. But again, that specific question has never been asked and answered.
They get all the risk up front. So
Yeah.
there's like the risk of the vaccine is much less than the risk of the chickenpox itself, although a lot of the headaches with the chickenpox vaccine is more like the isolation and parents staying home and the financial impact on the community, and that's really why it got approved, was because of what a big societal burden ended up having for how long people had to stay home whenever they contracted it. So
And what's interesting is that that's a disease that is much milder in young children than it is in adults, where it becomes a life-threatening illness. And so even some of our the diseases are artifacts of our society, that we've delayed exposure to a point that they become life-threatening, as opposed to if they were gotten and dealt with as young children. They would be much less, have much less morbidity. And a classic example of that is the polio infection, because it's been shown that when very young children with immature CNS systems get the polio, they are not at risk for the type of spinal damage that leads to paralysis. But it's the delayed exposure and the more mature CNS system that then puts the person at risk of getting the paralysis. So this is all it's really interesting, and there's so much work to be done to clarify these things.
another question that
right.
came up in the questions that I think would be really interesting to hear your take on is, it says, regarding the fight of a war on multiple fronts being less able to fight off new challenges, I guess I'm wondering how an infant's body in its first year can receive multiple different types of vaccines, sometimes three at once. Isn't it reasonable to expect the child's body with a fairly immature immune system may have an issue doing all of that in one day?
I'm going to give you my opinion, and I don't have research to back this up, but I think the answer to that question is yes. I think it is not good and ultimately not healthy to give a child 5 or 6 vaccinations at once. Our immune system just doesn't appear to be designed to respond in that way. It tends to take these things on one at a time. And I think to hit our bodies with all of these multiple antigens runs the risk of causing runaway inflammatory response that could ultimately result in damage. And I would say that if I were the parent of a young child, I would not allow that child to receive more than 2, maybe 3 vaccines at once. I'd probably try to limit it to 2 and just say, we'll come back for the others, because I don't think our system was designed to handle 5 insults at once.
I totally get that. I'm a family practice by background, but one of the things that happens is if you're trying to space them out, it means you get them later, and then you usually get shots at 2, 4, and 6 months, and what ends up happening is like you make the kids. Those are the kids who are kind of the most susceptible to getting super sick from those diseases, and they don't make a very good immune response to any of them because their immune systems are so wimpy at that point, especially if they're not being breastfed. And so then they end up getting their shots later. It kind of keeps delaying everything. Plus, they don't end up coming in for that many visits because they just can't manage it because it's a lot for parents. And then they end up being under immunized and more at risk. So it's like you can't
It's
win. Like
no,
low really be great is if you kind of did them on a schedule where they were, you're getting one per week and you had it cyclical, but just the
I would say one every 2 weeks,
Yeah.
since the
Yeah.
immune response seems to be about a 2 week cycle, and maybe we should do it that way. What's interesting is that I'm so old that I actually had the measles, I had the German measles, I had the mumps, and I had them when I was in grade school. And I, you know, again, I'm not an immunologist, and so I want to be real careful what I say. But what I remember was that the measles, I had a rash and a runny nose, and I got to stay home and stay up late for 2 weeks. The German measles was the same thing. The mumps hurt like hell.
I had the
And
mumps too.
yeah,
I'm older than I look.
yeah. And I
So
ended up having chickenpox so early, I don't even remember it, because my older brother was 4 years older than me, and he came home from school with it one day, and my parents put me in a room to play with him, and I had it and got over it, and that was it. So, um, um, I want to be clear. I don't know the answers to these questions, but I do think that there's a better way than hitting children with 5 or 6 vaccines at once, and that we need to maybe look at, well, what if we did space them out every 2 to 3 weeks for a period of time, and we could still get them in before they went to school, but it would allow them to get their immune system to deal with the antigen amount of response, get over it, and then be ready for the next one, and see if that was a healthier way to pursue this.
it might be work well for a kid who's home, a kid who's in daycare. The kind of exposure at school
Ah,
happens so
uh,
early that
another artifact of our society. Yeah,
yeah, yeah,
yeah.
yeah, yeah. They're just so exposed so early, and they're so at risk in those first couple of months compared to once they hit a year or a year and a half when their immune systems are much better. But anyway, questions that are not answered and we don't know the answer to because really we just don't know, not
But
studied.
it's important to ask them so that we can start to look at trying to get
Yeah.
answers to these questions.
Or picking out which shots you really, really, really care about. Which ones are really the most important ones to make sure that you get in. There was a question about why are some shots like you only have to get like the shingle shot once and then you're done and you don't have to keep getting boosters, whereas like with certain other things you got to get boosters all along, like every year. Can you talk a little bit more about that?
And it appears that the immune response wanes after a while, and that's a really good question as to why that happens. And is it because we're only using such a small part of the infectious agent that the body doesn't mount a quote unquote complete response, which is what allows it to wane over time? And I'm going to be honest, I don't know the answer to that question. I do know that the reason we require boosters is because it has been shown that over time the level of antibody starts to fall, and you kind of need that booster to keep it up.
You
But
also have things that change over time. Flu is not the
oh,
same every year.
yes.
COVID's constantly changing, so the boosters are made for
That's
the
an excellent point, because the COVID vaccine is actually changing enough that you need a new booster to get the new variant, kind of like the flu. It changes enough from year to year that you need a new vaccine to get the new variant. And one vaccine that we have to get every 10 years is Tdap. And I'm really concerned about the T, because when I was in medical school, I saw a farm worker who was in the ICU with tetanus, and it was a horrifying experience. And those bacteria out there in the soil, and they are constantly with us, even though we don't see them. And that's something that we really should be sure to keep ourselves immunized against, because, oh
did
my,
the farmer make it?
huh?
Did that
I,
farmer make it?
I don't know.
Yeah.
Because you know how you do a rotation, and
Yeah.
he was in the ICU
Mhm.
the entire period of my rotation, and boy, was he's sick as I don't know what.
Yeah. Tetanus is hard because it is treatable, but by the time somebody's getting stiff and it goes off in your head, like you recognize that it's tetanus, like you got like this tiny little window between the person starts getting stiff, you recognize it's tetanus, you get them on the right treatment and you save them. It's less than a day. So it's just like cutting it way too close.
Oh yeah, and he missed that window, and you instantly understood why the colloquial name is lockjaw, because I mean his entire body was rigid despite the fact that he was on paralytics. It was awful. Yeah.
Can you talk a little bit about the myocarditis that is seen in young men with the COVID-19 vaccine?
Yeah, that's a great question. And when you go back and look at the young men that this was seen in, they were young men who tended to be sedentary, obese, eating a very poor diet. In other words, who had high levels of inflammation in their body at baseline. And then when they took the COVID vaccine in certain susceptible people, it wasn't everybody, but almost certainly this had to do with probably MHC complexes and genetic susceptibility. That extra level of inflammation caused a self-limited myocarditis. None of those young men suffered permanent damage in these studies. They all eventually recovered and returned to normal cardiac function. And the level of myocarditis, which simply means inflammation of the cardiac muscle, was relatively mild to modest. It wasn't anything that put anyone in, as far as from the studies I've looked at, in the ICU on cardiac inotropic supportive medicines or ventilators. It was just pain, enzyme leakage from the cardiac cells, but it was self-limited. It did resolve, and there were no long-term sequelae from the episodes of myocarditis. But the key thing was this was in individuals who already at baseline had high levels of inflammation throughout their body. And it was not seen in other groups.
Can you also
So,
comment on
Wait,
the
Ted, did you have something to add about that?
no, but well, I do want to actually go into a lightning round at some point here because we have a whole bunch of questions that I would like to do in like 5 minutes.
Okay.
And
Can I just add one thing to that,
sure,
which was
go
I
ahead.
just wanted to make a comment about that myocarditis is a really common thing that develops in young men who have COVID, the disease. So
Mhm.
if you're infected with COVID-19, that is a common thing, and it's actually more common from having a COVID infection than it is from the vaccination in terms of what percentage of people develop it via vaccine versus the infection. And it tends to be much more severe if you get myocarditis and you've gotten the infection versus when you've got myocarditis from the vaccine. So it's not that it's not an issue, but it's
Yeah, but then it
relative.
typically resolves without long-term problems. And what would be really interesting is to know what role testosterone was playing in this, because clearly the
And
gender difference almost certainly has to do with the impact of the steroid hormones on cardiac muscle. So again, lots of really good unanswered questions we need to look at.
Mr. Barnett, do you want to lead the lightning rounds then? Go for
Sure,
it.
I would love to. Yeah, thank you, Dr. Graff. Stick around, please, because well, here's a question. Is there any advantage to taking Paxlovid as a healthy elder who gets COVID, or does it actually slow the healing? So the question is, if you get COVID, should you take the Paxlovid?
If a person got COVID and were symptomatic, I would do the Paxlovid. Because
Dr. Graff, do you agree with that?
I think it depends on the situation, the age and health of the person, right?
For
So
a healthy elder.
a healthy elder and they're eating a whole food plant-based diet.
And they're not that symptomatic. I mean, if they got like sniffles and mild congestion, then no, I'd just write it out. But if they're sick, febrile, serious chest symptoms, with wheezing or certainly if it causes their O2 sats to start to drop, or they start experiencing fatigue that interferes with ADLs, at that point I would. But no, if it's a mild self-limited illness, just as they say, put your big boy pants on and suck it up.
The problem is like if you wait longer to see whether it's going to get bad, then it's too late for the medicine to work. So it's kind of like one of these like, okay, if you have really, really mild symptoms on day 1, maybe hold off till day 2. But if you get to day 3 and it's more than kind of like a little
Yeah,
nothing, I would
then
definitely
pull the
take it.
trigger. Yes.
Yeah,
Mhm.
you don't want to wait. Once you wait to, you're a weekend and you're super sick, it's worthless. So,
Mhm.
but it
And I
doesn't
would say high fever,
side
definitely.
effects with it. It's pretty hard for a lot of folks to tolerate, and you do have the rebound issue, which is way more common than it was originally touted as being. So
Somebody wants to know if they should, their pharmacy keeps calling and telling them they need the vaccines for RSV and Pneumovax. What do you think about that?
All right, I'll tell you what I tell my patients. Pneumovax, yes, because pneumonia can and will kill you, and strep pneumoniae is out there, and typically by the time someone becomes aware that they had that infection, it's already advanced. RSV, I tell my patients, if you are going to be around young children who are typically the carriers and vectors for RSV, then yeah, you should, if you got grandkids or anything like that. But if you are kind of like, living your best life, doing your own thing, and you're not around a lot of young children, I tell people it's up to them, but I don't push it.
Okay.
COPD, I would definitely get it.
Well, yeah, I
Or
mean,
asthma, if you got any underlying lung issues.
certainly pre-existing conditions. Thank you,
Diabetes,
Dr. Graff,
we push,
because
but
I'm always thinking of healthy people. But no, you're right. Absolutely. If you've got severe asthma, COPD, or some fibrosis, or some other
autoimmune disease, like if you're immune suppressor, if you're on an autoimmune disease, I always think your immune system's just not working right. Get the vaccine.
yeah.
Okay, one more question, and then it's going to be 9 o'clock, and we're going to call it a night. I'm making an executive decision, but this is kind of interesting because it has to do with how mRNA vaccines works. So if the COVID vaccine instructs the body to produce the spike protein, how long does the body produce the spike protein, and what stops the body from continuing to produce it? Anybody know the answer to that?
I don't know the definitive answer. I would suspect that it's just like when I think it's probably analogous to when any of our cells are invaded by a virus that hijacks the cell to turn into a virus factory. Eventually, our immune cells become sensitized to that, search out those virus producing factories and kill them. So I'm assuming that is the similar process, that we turn some cells into spike protein manufacturers. They make antibodies against the spike protein, and then those viral factories are recognized and eliminated.
All right. Well,
That's supposition.
Yeah, well, this is supposition for me too, but also messenger RNA is designed to only last for a brief amount of time, right? That's the whole point. Your cell decides, right? Your cell decides to make a particular protein.
Bob Ricky just put in the chat. It degrades into harmless RNA pieces in a few days. Thank you,
Okay.
Bob.
Yeah, Bob, thank you.
Okay.
That's kind of what I figured. Good. Thank you for that, Bob.
It's Dr.
All right.
Bob Ricky. He's amazing.
Yeah, thank you, Dr. Brabecki. Anyway, Milton, this was brilliant. Dr. Mills, thank you so much. Dr. Carrigraph, thank you for joining us. Thank you to our engineer tonight, Bob Brakey, and all the staff at RLMI. And thank you
Frankie.
all. Yeah, what's that?
Bob Frankie, not Bob Ricky, who's the engineer
Oh,
tonight.
but did I say Frankie?
Yeah,
Brakey?
there are too many Bobs.
Oh, yeah.
They're all
Thank you to Bob
amazing.
Frankie, our engineer tonight.
Yeah.
And it's very confusing. All right. With that, we're going to say goodnight, and we'll see you next time. Take a
My
look at our
pleasure.
schedule.
Pleasure,
All right.
everybody.
Bye-bye.
Inviting me.
Take care.
Yeah, thanks.
All right. Bye-bye.
Bye-bye.